if I remember, the algebra gets a little fun on this one. So you go u of n plus 1 minus u of n. We're going to check for monotone increasing or decreasing. The checking for the first and the last is really easy for this one. What's n1 going to be for this guy? When n is equal to 1, 3 over what? 3 over 4. What is n going to infinity going to be? 3 to the n, forget about the 1. 3 to the n over 3 to the n is what? 1. So what do you anticipate this to do if it is always increasing or decreasing? What do you think it's going to do? Why? You're starting at 3/4 and you're going to 1. So it's probably going to increase. Let's see if that's what we get. So you have 3 to the n plus 1 over 1 plus 3 to the n plus 1 minus 3 to the n over 3 to the 1 plus 3 to the n. My guess is you don't like that. Am I right? Yeah, you don't like that. So let's make it a little breezier. This is 3 to the n times what? How many 3 to the n's is this? 3 to the n times 3 to the 1, which is how many 3 to the n's? 3 of them. 3 to the n's. Minus 3 to the n over 1 plus 3 to the n. Okay, now we're going to have to multiply by the other one. 1 plus 3 to the n. 1 plus 3 to the n. 1 plus 3, 3 to the n's. 1 plus 3, 3 to the n's. And this is going to be 3 to the n's plus 3 to the n plus n, or 3 to the 2n. 3 to the n times 3 to the n. Do you see how you add these two n's to get 2n? Okay. Minus 3 to the n minus 3 times 3 to the 2n, all over 1 plus 3 times 3 to the n times 1 plus 3 to the n. The bottom just looks horrible. You don't have to do anything with it. Hopefully something cancels out in the numerator. Does it? What cancels out in the numerator? 3 to the 2n's. So what you'll be left with, well, 3 to the n's minus 1 3 to the n is how many 3 to the n's? Huh? 2 of them over 1 plus 3 to the n plus 1, if you want to put it that way, 1 plus 3 to the n. Now, if n is always 1, 2, 3 positive, what's it going to be in the numerator? 1, 2, 3, 4. It's always going to be what? Positive. What's it going to be here? 1 plus 3 to the n plus 1. Positive. What's it going to be here? Positive. So this is always going to be what to 0? Greater than 0. So we would say always increasing. Well, then we'd go back and we would put the whole thing together, and we would say, therefore, since always increasing from 3/4 to 1, and you can say n equal to 3/4 to n equal 1 if you want, then sequence is bounded by definition, if you want to add that. You like it? It's doable, isn't it?